What's going on, guys? I just want to take a minute and talk about some basic rational functions and how transformations could affect them. And I kind of just want to investigate this graph like y equals 1 over x. So if you think about this graph, essentially, it's the most basic rational function you can have. You basically have a constant over a linear monomial, right? So if you look at this graph, a couple things, like obviously there's one value that you can never have for x. So think about this. What value would we never want on the denominator? It's 0, right? So since it's just x, we just say x cannot equal 0. And so what's going to happen there is you're just going to have this vertical asymptote at 0, right? If you look at this, the bottom has a larger degree than the top. The bottom has a degree of 1. The top has a degree of 0 since it's a constant. So we know the bottom's bigger than the top. We know that there's a horizontal asymptote here. So what ends up happening is you basically just have this thing that kind of looks like this. It kind of hugs those asymptotes like that. And you just have this basic graph. If you want to see a better one, maybe we could graph it on the calculator and you can kind of see, okay, there it is right there, right? Okay, so all I want to do is talk about maybe a couple transformations here, a couple easy transformations is how that would affect the graph, all right? So let's think about this real quick. If I take this graph, that's 1 over x, right, which we just saw what it looked like, right? And you did something like this. You did like a +2 on the end, okay? What do you think that would do to the graph? Okay, well, if you think back to transformations, right, basically that would move the graph up 2 units, right? So let's think about what that would change. If you had that original graph just sitting right here, right, and you moved it up 2, right, what do you think that would change about the graph? Well, let's take a look. If I just put a +2 behind here, right, just a little +2, and hit graph, you'll notice the whole thing went up 2 units, right? So all that happened there was, remember how there was like a asymptote here at 0, right? Well, it now went up to 2 like that, right? See that? And this thing just is chilling right here. So basically you go like that, you go like that, right? And voila, you got your new graph, right? Well, a couple things happen here. Basically, you now have an x-intercept, right? And we'll talk about that in just a minute. But um, yeah, I mean, essentially, you look at this graph, it just basically moved the other one up too. Now, if you want to think about in the way we've been talking about it, if you put this over 1 like that, a 2 over 1, what would be the common denominator here between this x and the 1? Well, it'd be x. And if you gave this, look, an x over x, here's what you get. You'd have like a 2x, right, plus 1 all over x. Now let's take a look at this function right here, 2x plus 1 over x, okay? Who has the larger degree, the top or the bottom? Well, guess what? They both have a degree of 1, right? So if you look 1 over 1, well, 1 and 1 are equal. So if we went to the lead coefficients 2 over 1, what's 2 divided by 1? Well, guess what? We get that 2, right? What still makes the bottom equal 0? Well, it's still 0. You notice that didn't change. But now, if you wanted to find this x-intercept right here, you could say, okay, well, what makes the top equal 0? Well, guess what? If you said 2x plus 1 equals 0, and you solve for that, subtract 1, divide by 2, you get x equals -1/2, right? That's where that intercept is, right? -1/2. But basically, long story short, all this did was it took that original graph, right? It took that original graph and it moved it up 2, right? Moved it up 2 units, okay? Well, we could also do something like this. Say you have that original graph, like y equals 1 over x, right? Okay. And let's say I go in there and I do something like this. Y equals 1 over x minus 4, something like that, okay? Well, what happened here is since I went just into the x, if you recall, that's like a horizontal translation, okay? Essentially what happens there is you go the opposite direction, so that would actually be right 4 units, okay? So think about this. This one over here, copy graph, but this one kind of looked like this, right? If I would move right 4 units, what's going to happen is that asymptote is now going to be over here at 4, and it basically just does the same thing it did before, right? So you basically have this function right here, okay? So that moves it to the right 4, and that would change the domain. So obviously, if we looked at this, we would know that the domain is x cannot equal 4, right? And that's where we get the vertical asymptote. So essentially what's happening here is that when you go into the x, you're just basically going left or right, okay? So just a couple quick things I want to make sure you make note of is if I gave you a function like y equals, let's say 1 over x plus 2 minus 1, okay? So say you looked at something like that, right? Y'all help me out. This took that parent function. Remember, the parent function is just y equals 1 over x, right? Y equals 1 over x. This took this parent function. If I put a plus 2, that actually went left 2, right? And then what did this do right here? That would be down 1. Left 2, down 1. So essentially what happens is, you know how that we have that vertical asymptote at 0? It would just go left 2. So we'd have a vertical asymptote at x equals -2. And then the horizontal asymptote, I promise you, would be at -1. So watch what I know here. This is pretty cool. Watch what I know. I know that the vertical asymptote will be at -2. And the the horizontal asymptote will be at -1. So if I just go -1 like that, that's what it's going to look like. And a general graph of it would look like this right here. Okay, see that? And I can prove it to you. Watch real quick. I'll just take my calculator. And so like, watch this, 1 divided by parentheses x plus 2 close parentheses, right? And then subtract 1 from the whole thing. You can kind of see that that's exactly what we have, right? We have that -2 as the y, or as the vertical asymptote, excuse me, and -1 is the horizontal asymptote, right? So you can kind of see that the opposite of this is going to be your vertical asymptote, and this is going to be your horizontal asymptote, right? And if you wanted to, if you're like, man, I just really like the old way we did it. I mean, you could get a common denominator here. You could multiply this by x plus 2 over x plus 2, right? And what you end up with there is you end up with 1 minus 1 parentheses x plus 2 all over x plus 2. And watch what this ends up being. If you distribute that at -1, you get 1 minus x minus 2 over x plus 2, which equals -x minus 1 over x plus 2. Now, help me out here real quick. Okay, let me show you that. See that? So essentially what happens here is, look, what makes this bottom equal 0? Well, it's -2. Bam, there's that, right? Who's got a larger degree? Well, they're equal, right? And if you took -1 over 1, you get a -1. There you go. And you could even find things like the, like the x-intercept if you wanted to. What makes the top equal 0? Well, it's going to be a -1. You can see it right there. Okay. And all kinds of stuff, the y-intercepts can be -1/2 and all that. So you could go back to where you had it. But I'm just trying to tell you, just a real quick rule. If you ever have a parent function y equals 1 over x, and you transform it, you can easily see the asymptotes and all that stuff. So one more time, y equals, let's say, 1 over x plus 7 plus 10. This has a horizontal asymptote at y equals 10, and a vertical asymptote at go left 7. That's x equals -7. Okay, so I mean, you could flip it and stuff, obviously, by messing with the top numerator. You can make it negative and make it, instead of going like this, it would go like this. But just a real quick rule of thumb, if you ever have it in this form, this is going to be your horizontal asymptote. The opposite of that will be your vertical asymptote. It's just based on these transformations, all right? So just a quick thought, but like I said, you can always put it back in the form we had it by doing common denominators, and you're back to the same thing. Okay, so saying that, no big deal, but I just wanted to mention that to you you guys start on the review. So hope you guys have a great day today in class, and I'll talk to you next time.